All right, 12.8 is the probability of what we call compound events. Compound events means I am doing more than one experiment at a time, or more than one decision at a time. And the key thing about this is that there's two types of compound events, which is and or. When you're performing selections with and, you multiply your probabilities. So 7 red toys, 5 blue toys in a bag. What's the probability of selecting a red and then a blue toy? And the important part, first car is not replaced. So keep this in mind. You have 7 reds, you have 5 blues. You want a red car first. All right. So the probability of selecting a red car on your first decision is 7, because I want red, out of, looks like 12. All right. What about your second decision? Well, the probability of selecting a blue car is 5. But here's the thing. The first car is not replaced, so my total number will not be 12. Because if I chose a red car, I now have 6 reds, which means that it should be 5 over 11. And that's where you have to be careful. If it's not replaced, your total is going to change by 1 because I did not put the car back in the bag. Again, there were 7 reds, 5 blues. Assuming on the second that I picked a red, I took a red out, which means there's only 6 reds left, and 5 blues, which means there's a total of 11. So then you take those two probabilities and multiply them, which again, you can do this on paper because it's top times top, bottom times bottom. I don't know if that's reduced, but I'm pretty sure it is, which it is. And again, if they wanted the decimal, convert that to 0.27. If they wanted the percent, it's 27%. But again, you should know how to kind of change those routes. And if not, email me and let me know. Same question, different style. Again, 8 red toys, 9 blue toys. What's the probability of selecting a red and then a blue if the first is replaced? So again, 8 red, 9 blue. First selection, again, if I want a red, it's going to be 8 over 17 because there are 8 reds and 17 total cars. The difference in this question is that when I want a blue now, it'll be 9 over 17 because remember, if I took the red out of the bag and then I put it back because it is replaced, then I still have 17 to choose from. So my first percentages or first probability is 8 over 17. My second is 9 over 17. Because I am doing both in and, I will multiply those two and end up with 72 over, I believe it's 289. Yep, only because my teacher made me memorize those. So again, 72 over 289. If they want the decimal, you should know how to convert that. If they want the percent, you should know how to convert that. So just keep that in mind and make sure you're good to go. You have a bag of 3 red marbles, 8 white marbles, 5 blue marbles. You choose a marble, replace it, and then choose again. You want the probability of red and white. What's the probability of choosing a red marble? Well, that'll be 3 out of 3, 11, 16. What's the probability of choosing a white marble? Well, there are 8 good marbles to choose from. The question is, how many total? It says I replace it. That's key. I replaced it, which means that my total number should not change because I put it back in the bag. That means that this is 24 over, I don't know, 216? I have no clue. Or is it 256? I don't know. 256. I always mess up on that one. Anyway, 24 over 256, which of course is reducible because both of those are even. So 3 over 32. Or again, if they want the decimal, give the decimal. If they want the percentage, give the percentage. But again, you should not have an issue doing that. And if you do, let me know. You have a bag of 7 red marbles, 4 white marbles, and 3 blue marbles. You choose a marble, then choose again without replacing it. The key here is you're not replacing it. So on your first pick, you want a red marble, which means I have 7 total out of 7, 11, 14. And the key here, because I'm not replacing, is on the second marble, if I want white, then it'll be 4 out of 13, because remember, I did not put the first marble back into a bag. So it's 7 14ths times 4 13ths, which is actually 1/2, times 4 13ths, which is 4 over 26, which is 2 over 13. And again, if you want the decimal, convert it. If you don't, if you want the percentage, convert the decimal, whatever you need to do on that. So or, whenever performing selections based on or, you add your probabilities. So you have to kind of write that down and make sure you've got it. And means multiply, or means add. Make sure you know it. That's the key idea. So you have a bag of 3 red marbles, 8 white marbles, 5 blue marbles. What's the probability of selecting red or blue? So my first is red. Red would be 3 out of 3, 11, 16. Now here's the thing. It doesn't matter with or because I'm not selecting twice. I'm selecting once, which means my total does not change. It's still out of 16. But if I want red or blue, then I would now do 5 out of 16. So my first pick, I'm sorry, it's not. I guess it's first or first. Because again, you want this or that. So again, I want 3/16 if I have a red, 5/16 if I have a blue. So all I will do, because this is or, is add those two together to get 8/16, which means I end up with 1/2. Or we could do it this way, visually. Red, 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 white, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5. People are calling me like crazy once I start working. I don't get it. Anyway, so in this case, if you list everything on an or, you just pretty much say these are good selections. Those are good selections. 1, 2, 3, 4, 5, 6, 7, 8 of them out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And that's what I ended up with anyway in or. With or problems, you can actually look at it that way and still get what you need out of the idea, which is honestly what I'm going to do on this one. There are 4 red chips numbered 1, 2, 3, 4, 7 white chips labeled numbered 5, 6, 7, 8, 9, 10, 11. This is way too complex to do using probability because you want red or odd. And so what I would do is kind of list it white. And I would circle the ones that work. So you want red or odd, which means these are all good choices. Even though that's even, it's still red, so it does not matter. And then these would be bad choices, but if they are odd, that makes them good choices. So good choices represents 1, 2, 3, 4, 5, 6, 7, 8 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which again, that would be your fraction. If you need a decimal, convert it. If you need a percentage, convert it. But that's the general idea. Again, be sure you communicate with me on this stuff. There is no way really to learn statistics outside of messing up and asking questions. So just be sure you're ready to do that. And outside of that, have a good day. I'll talk to you later.